Hi everyone. I'm just going to look at a conservation momentum example today. This one involves a woman riding a bicycle, which is I found a picture of a penny farthing and I always like to throw them in. So I have a 40 kilogram woman riding on a 10 kilogram bicycle. She's moving at 4 meters per second westward. She jumps off the bike and continues moving westward at 6 meters per second. What is the velocity of the bicycle after she jumps off? So I've made a picture because pictures I always find them helpful. And I encourage you to draw sketches if you can too. They don't have to be fancy, but here's the scenario. She's riding the bicycle. They are together, her and the bicycle beforehand, and then after they are separate. So if I look at these two scenarios and I look at my formulas, it's the two together and then separate. So this is an explosion or separation type question. So I'm just going to write explosion / separation. And the formulas use A and B and C, but we don't need to use A and B and C. I'm going to put my givens down on here. So I'm going to, mass of the woman is 40 kgs. Mass of the bike is 10 kgs. And they're together. And the velocity of the bike and the woman together beforehand is -4. Remember, we're going westward. That's where the negative comes from. After they separate, so the mass of the woman is still 40. The mass of the bike is still 10. But the velocity of the woman is now -6 meters per second. And we're looking for the velocity of the bike, which has a little prime on it. So we need an explosion equation. And I like to put the letters this way so that I can look at them and go, I know it goes with what. So the formula would be MW plus MB for bike. So they're together beforehand with one combined velocity, and then after, the mass of the woman times the velocity of the woman plus the mass of the bike plus the velocity of the bike after. And that's what we're looking for, is this right here. So I'm going to plug the numbers in. So I just pause this, plug my numbers in so you could see them. The total mass times the velocity of the bike beforehand, and the mass of the woman times her velocity. This is -200, that's -240. I move the 240 to the other side and get a +40. So the velocity of the bike would work out to be 4 meters per second. And if you think about it, they're going 4 meters per second combined, and she increases her velocity. That means she probably kicks the bike backwards. So initially, she gains some velocity the other way, and the bike goes the other way. It's kind of like the recoil of a gun. So hopefully that makes sense. Take a look through that, check that out. But that's basically the way we do all these questions. Separate them, letter them by what the objects are. So you'll notice in the examples they're lettered that way. And then it makes it easy to put them together. And if you, sorry, not those two, this one and this one. And if you label them easily, then you can put them together easily. All right, hope that helps. Thanks.